In this video, we're going to solve this system of 3 by 3 equations, and I'm going to do it using row reduction, which is a little bit like elimination, and it has its roots in vectors. So the first thing I'm going to do is I'm just going to write those equations out, but taking off the x, the y, and the z, and then just putting the answer in there. So we've got a row there and a row there, which is 2, 3, minus 1, and so on. Now with row reduction, what I'm going to do is I'm going to make this a 0 and this a 0 on my first pass through. Now to do that, I've got this matrix. So a few things to note. Before we do any arithmetic, the first line is exactly the same. Now the second line has got a 0 for x in there. And how I've got a 0 for x is simply by doing 3 lots of row 2 and then taking away 2 lots of row 1. So how did I do that? I times that by 3 and took away 2 lots of that. So 6 take away 6, 0. 9 take away 4, 5. Minus 3 take away minus 2. And so it's going to give you a plus, so I'm going to have plus 1. And then 0 take away 2 lots of that is minus 6. I'm also going to get a 0 from here. And to get that, I'm going to do row 1, take away 3 lots of row 3. So that take away 3 lots of that gives me the 0. That take away 3 lots of that is going to give me 14. That take away 3 lots of that is going to give me minus 7. And 3 take away 3 lots of 21 is going to give me minus 21. The next line, what I want to do is have this one here is the same. This line here, that's the same here. But the bottom row, I'm going to try and make either this a 0 or this a 0. So I've actually managed to make this a 0 by doing this one take away 7 lots of the top line. So it's row 3 take away 7 lots of row 2. So this take away 7 lots of this is minus 21. This take away minus 1 times 7 is giving me 0. And this take away minus 7 times this is going to add on 42. And now we've got this line here. From this line here, we can see that minus 21, and this is the y column, always the y column, equals 21. So from here, I can see that y is minus 1. Now this is quite straightforward to work out all the other answers now. So y is minus 1. Let's look at this line here, which just has the z's in it. So we're going to have 14, and y is minus 1, so that's going to be minus 14 minus 7z's equals minus 21. So basically 7z add 21 to both sides is 7. So z is 1. And finally, then we can look at one, maybe the top line, which has x's in it, 3 x's, 2 y's, so it's going to be 3x minus 2 minus 1, and y is 1, z is 1 rather, so minus 1z equals 3. So add 3 to both sides and get ahead of myself, and I'll make 6 here, and x is 2. And so this one has unique solutions where there's a value for each one. Now, if you watch further videos, you'll find that there's not always unique solutions. But this one, there's unique solutions. And by the way, I can do it on a graphic calculator. So let's just go back. I'm going to show you how I get to this part here. If I'm in my menu, I can go to my equation. I can execute. And I've entered that 3 by 3 matrix in there. Okay, in fact, that's exactly the same as that first one here. And if I press solve, by the way, if I just come out of here, I actually got there by doing simultaneous equations, 3 unknowns, and I entered it. And press solve, x is 2 down there, y is minus 1, and z is 1. But I do need to know how to do these without a calculator as well.